slope, and then we discussed the formula to compute the slope, and then we did a bunch of examples on how to come up with the slope and the y-intercept of a line given the equation. Okay, let me do one just to remind you of this, and then we'll continue with the other idea. So recall. So first of all, the slope of a line, we call it m. This is the letter that we use, and we have a little formula for it. All you need to compute the slope is 2 points. Okay, so let me say slope of a line given 2 points. Given 2 points on it is given by the following formula. Who can tell me?
Yx plus b.
So that's the equation of the line. So the slope. So if I give you 2 points on it, let's say x1, y1, and x2, y2. So you have 2 points on the line. How do you compute the slope?
y2 minus y1.
Over?
x2 minus x1.
x2 minus x1. So difference in y's divided by difference in x. Okay? So this is what we normally call the rise, but this is only when it's going up. If it's going down, this is really a fall. Okay? This is the rise, and this is what we call the run. Okay? Rise over run. Okay. And then we also know that the equation of a line, there is a special form. Okay? So we have the slope intercept form, which is what your class was saying. So what is it? Mx plus b. And who is this guy? That's the slope. And what is this?
The y-intercept.
That's the y-intercept. Okay, good. So I'm going to give you an equation just to practice what we did last time. I'm going to give you an equation that's not going to be in this form. It's going to be in a standard form. And then I want you to find the slope, the y-intercept, and use that information to draw the line. Okay? Instead of doing tables, we don't need to do tables anymore. Instead of doing a table with points and so on, let's use the slope and the y-intercept for that. So, example, find the slope and the y-intercept. Then use this to graph. All right, and then the equation is 3x plus 4y equals 4. Okay, so this is what we call the standard form, but again, it's a linear equation in 2 variables, so you know the graph of this is going to be a line. So first, let's figure out what's the slope and what's the y-intercept of this line. And of course, you can do this many different ways, but the idea is that since you want to find the slope, if you don't want to use the equation per se, you have to come up with 2 points. If you want to use the above formula, what you need to do is find 2 solutions here and then use the formula. That's a lot of work. You can actually use the fact that if you write this in a slope intercept form, the number that's in front of the x is already your slope. Okay, that's the fastest way. And the number that's by itself here is already your y-intercept. So you kill 2 birds with 1 stone. Okay, so let's just solve for y and write it in a slope intercept form. Okay, so solution. I'm just gonna solve for y. So you have 3x plus 4y is equal to 4. We move the 3x over. So we're going to get negative 3x plus 4. So 4y equals negative 3x plus 4. And now we divide by 4. Remember, when you divide by 4 both sides, every single term has to be divided by 4. Okay? So divide by 4, divide by 4, and divide by 4. So we get that y equals negative 3 over 4x plus 1. Are there any questions about this? So now we have it in the form a number times x plus a number. So this is the y-intercept form. So from here we can immediately say what we need. So what's the slope?
Negative 3 over 4.
Negative 3 over 4. And what's the y-intercept? So give me the point. Remember, point is x comma y.
Negative 3 over 4, comma 1.
Negative 3 over 4 is the slope. What is the y-intercept?
0,
0,1. Remember, we say this is the y-intercept, but this is just the y value. The point is 0, whatever the y value is. Okay. All right. Any questions? Okay, so now let's go ahead and let's use this information to draw the line. Again, all of this was done on Tuesday, okay, and just summarizing what we did. We did more examples on Tuesday, but let's do a couple. I mean, just doing this one. Okay, so remember, to draw a line, there is no escape. You need 2 points, okay? The question is, how do you find these 2 points? If you have your equation, what you could do is what we were doing before. You do your table, find solutions, plot them, and then you're done. Or, if you already have it like this, that you know the slope and the y-intercept, you can use that information to get your 2 points, okay? So let's practice that. For example, we already have 1 point, so let's use it. We have the point 0, 1. So it's right here, okay? We know our line is going to pass through this point. We just need another point, and then we're good to go, okay? Now, let's use the slope for that. First, we need to decide what's the line doing. Is it rising or falling? So is the line going up or down? Down. Why?
Negative.
Because it has a negative slope. So this is less than 0, so the line falls. Okay, it's going down. So that means the other point is going to be somewhere down here. Okay, where is it? Let's use the slope. So remember, instead of rise, it's really fall over run in this case. Okay, if it was positive, you would do rise over run. But here is fall over run. So if you are at this point, which is 0, 1, what would be the new point? Who can tell me?
I would go down 3 to the right 4.
Good. So we go down 3, which is, where do we stop?
Negative 2.
And negative 2, because we started at 1, right? So you do 1, 2, 3. Yes? Down to negative 2, and then 4 to the right. This is a 0, so we go all the way up to 4. So here is the other point, and as usual, once you have the 2 points, you can draw. Okay? All right. Any questions? Did you understand this? So this is basically the summary of all the information that we did on Tuesday, okay? How to understand this, and then we did a bunch of examples, etc. So as you can see, the slope is very useful. The slope tells you, how to draw the line if you only know 1 point, okay? And it tells you where the line is going up or is going down. Let's look at another feature that the slope also tells you about lines, okay? So what I do now is we want to compare lines. If you're given 2 lines, 2 things can happen. Either they cross or they don't, okay? And if they don't cross, what happens in that case? There's only one special situation in which the line won't cross. How must they be? What can you say about these lines if they don't cross? That's what it means to be parallel. Do you know what parallel lines are? It means they're going in the same direction, okay? But they never cross. So they are always in the same direction, keeping the same distance from each other, okay? If they have a different direction, like a slight inclination, at some point, they're gonna cross. Do you understand this? Okay? So we want to use the slope to be able to tell this, okay? So let me write this down. So this discussion is about parallel and perpendicular line. I'm gonna get to perpendicular in a second. Recording, right? Yes. Perpendicular lines. Okay, so the first observation is, so remark, given 2 lines, let's call this line L1 and L2, okay? So given 2 lines, 2 things can happen. So first, the lines don't cross. In which case, there are many pictures that I could draw with this situation, but I'm just gonna pick one. Let's say here is line 1, and then here we have line 2. Okay, the point is that they are going in the same direction, okay, all the time, keeping the same distance between each other. So the lines don't cross, and then the second situation will be that the lines cross. So, for example, let's say L1 is going this way, and let's say L2 is going this way. So as you can see, by the way, it should be clear to you that if lines are going to cross, they will cross at one point. Do you understand this? Cannot cross at more than one. But now, this picture may be deceiving because because here I'm showing you a picture with a line with positive slope and a line with negative slope. They both could have positive or both negative slopes. All you need is a different inclination, that's all. Here is a picture with both lines with positive slope, okay? There are many pictures that you can draw. So the point is that there are two main cases. Either they don't cross or they cross, okay? We would like to tell these two cases apart. So let's see. Why is it that these lines don't cross? By the way, we call this parallel line. Let's give these names. So the situation is parallel lines. And then, of course, situation like this, the lines are not parallel. So, because the lines are parallel, that means that they have the same direction. And remember, the slope is a way of measuring the direction of a line, okay? So, if they have the same direction, what does this mean about the slope? What do you think this means about the slope?
The same slope.
They have the same slope. Do you understand this? They have the same slope. So, two lines are parallel if and only if they have the same slope. So, what we see here is that they're going to have the same slope. Okay, so for example, if line 1 has slope m1, whatever number this is, that's going to be the same as m2. Okay, the same slope. And over here, because they are crossing because they are not parallel. In other words, they don't have the same direction. So what does that mean in particular? That the slopes are different, right? So different slopes. In other words, if you're given two lines, and let's say that you're not given the picture, but you're given the equation, okay? If you're given two lines and you're asked whether the lines are parallel or not, all you have to do is look at the slopes. If the slopes are the same, they are parallel. If they are not the same, they are not, okay? So M1 is not equal to M2. Do you understand this so far? This should be clear. So looking at the slopes, you can tell whether lines are parallel or not. Now, let's say that they are not parallel, so they have different slopes, okay? There is a special case that we want to distinguish from here. If the lines are crossing, we want to be able to tell when they do so at a special angle. In other words, at 90-degree angles, okay? So, in this second situation, we have special case. Which is crossing with a 90-degree angle. How are the lines called in this case? So when they don't cross at all, they're called parallel. How are they called when they cross with a 90-degree angle? Do you remember this from high school geometry? Perpendicular. Lines are said to be perpendicular if they cross at a 90-degree angle. Okay?
So what are those called? Aren't those perpendicular?
They are not perpendicular because, I mean, I'm not telling you what the angle is here, but this angle doesn't appear to be 90. Like 90 degrees is a right angle.
So then how would you describe those lines?
Just not parallel.
Not parallel, not perpendicular. So in this case, we would say they are needed because what we are interested in when you're given two lines is want to know whether they are parallel, perpendicular, or needed. Okay. All right. So crossing with a 90-degree angle. So this is the word that we use for this is perpendicular lines. So let me draw a picture of that. Say that this is L1, and then L2, it crosses with L1 in a special way. So it makes here a 90-degree angle. So typically, when we have a 90-degree angle, we do a little box to show that it's a 90-degree angle. Okay? For example, every rectangle, every square has a 90-degree angle in its corners, the vertex. Okay? So we want to be able to distinguish here. Okay, yes, we know the slopes are different, but the slopes being different doesn't tell me that they are perpendicular because that also happens in these situations. Okay, so how can we tell that we have a 90-degree angle at the point of intersection? So I'm going to give you a little theorem. Actually, let's investigate that and then we will write the theorem. So from here, so in the special case, means the lines are perpendicular. So the question that we want to say is, what can we say about the slopes? So can we use the slopes to help us out, to distinguish this situation, okay? Well, the first thing that we can say is, well, they are different, right? So definitely M1 is not the same as M2. Because if they are perpendicular, they are definitely in different directions, okay? They are not parallel, they are crossing. So we can say for sure they are different, but that's not enough. We also have the other cases with that situation. So what's special about this that's not happening in the others? At the 90-degree angle. So let's exploit that. Let's see. What's special about having a 90-degree angle?
Does that mean that the slopes are the same? One of them is negative though?
We'll see. We'll see. Actually, that's a good point. If they cross a 90-degree angle, and they say that none of them are zero, because there's a very special case here. If you have a line with zero slope, that's a horizontal line, then the perpendicular to it has to be perpendicular line, right? So in this case, the slope is zero, and in this case, what's the slope of the second one? What happens to perpendicular lines? It's undefined. The slope does not exist. Okay? So this is a very special case. When you have a horizontal line, it's perpendicular line, it's a vertical line. Vertical lines, remember, the slope is not defined. Okay? It does not exist. But so, avoiding this case, let's say that we don't have this case, meaning that the two lines have slopes, both of which are different than zero. Okay? So this is special case. Let me put it here. Leave it there. So that's a special. So let's say M, but here let's consider M1 different than M2, and also let's say both M1 and 2 are different than 0, okay? Because if one of them is 0, then the other one is not defined. So we already have that case written down. Another observation, like your classmate made, if the lines are perpendicular, one has to be going up, the other one has to be going down. There is no way that they can be both going up and cross at a 90-degree angle, okay? So I mean, we can say for sure that one is positive, the other one is negative. Which one is it? We don't know. But what we can say for sure is that the slopes have different signs. That means one is positive, the other one is negative. How can you say more fancy that two numbers have different signs? If you don't know which one of the two is it, but you know that they have to have different signs, how can you say this in a fancy way? If the product is negative, right? The only way that you can multiply two numbers and get a negative result, what is it? The one is positive and the other one is negative. Because if they have the same sign, you will always get a positive result. Yes? So in other words, if you were to multiply the two slopes, you're going to get a negative number. Does everybody understand this symbol? We're going to talk about inequalities next. But do you understand this symbol? Right? This means less than. But we talk about this? Yes, we talk about it. We did linear inequalities in one variable. Just that we're going to do two variables soon. But yeah, we'll talk about this. Okay, so that means the product is negative, okay? We want to actually know, can we tell what this equals to? Okay, and that will actually be the characterization. We know it will be a negative number, but the question is, what is it? Can we figure this out? We can figure this out, then we're good to go. So let's do it. There's something very special about the 90-degree angle. And think about the following. When you have a picture in the plane, there are some operations that you can do to the picture. Like you can do rotations, you can do translations. For example, if I move this picture over here, it's essentially the same picture. It's just that it's in a different place of the screen. Okay? Now, what I want to do is I want to rotate this picture. Stay there, but I will rotate it. Now, depending what rotation you do, you may or you may not change the picture. Okay? In this case in particular, because this is 90-degree angle, if I were to rotate this by 90 degrees, what's going to happen? The blue line is going to become the red line. And the red line becomes the blue line. So we have the same picture. Do you understand this? If I take this and I rotate it 90 degrees, I get the same picture. So we're going to take advantage of that. So note, I'm going to have here my picture. And I will need space. Go here. So here is L1. Here is L2. Okay. And then, because I want to talk about the slopes, So I'm just gonna pick another point here in L1 and let's write down the slope of L1. So the slope, as you know, is rise over run. So let's call this, whatever it is, let's call it A, and then this one here, let's call it B, okay? So from this picture, we get that the slope M1 equals what? What is it? A and B are numbers, okay? I don't know what they are, but they are numbers. So what's the slope of the first line according to this picture? Remember, to complete the slope, all you need are 2 points, and then when you have the 2 points, if it's going up, you do your rise over run. If it's going down, you will do your fall over run, okay? So in this case, what will be the slope using A and B? A fraction. You have to give me a fraction. A over B, right? I don't know what they are, but there is a slope there, right? Do you understand this so far?
Yeah.
So now I want to compute the slope of M2. But instead of looking at this picture, I'm going to rotate it. I will end up with the same picture, okay? But let's rotate it. So remember, this is 90-degree angle, okay? So now let's rotate by 90 degrees. So what's going to happen is that now we're going to have the blue here. I'm going to have the red here. But still, it's just they are going to change color. But still, this is now L2, and this is L1. In other words, they change color, right? So what was red now becomes blue. So the red takes the position of the blue, and then the blue takes the position of the red when you rotate. Okay, it's the same picture, but again, this is still line 1 and this is still line 2. You understand this? The same line, you just change color, basically. But when you rotate, now this triangle is going to rotate with you. Yes? So let's draw this triangle. Where is it?
It's on top now.
Let's see.
Oh, triangle, sorry.
So let's see. This point went up here, yes? We did the rotation, so the second point is going to be up here. And then this side, the side A, that's vertical, when you rotate, how is it going to look like? Horizontal, right? It's still A, because when you rotate, you don't change distances, okay? That's called an isometry. Translations and rotations, they don't change distances. So if you have this distance, you rotate, still the same distance, okay? So that means this is still A, and then this one that was horizontal, when you rotate, becomes vertical, okay? So, and this is B. Do you understand this? So this little triangle, when it was rotated, it became this one over here. But now we can use that triangle to find the slope of L2. Who can tell me what's the slope of L2? Let's see, is it positive or negative? It's negative because the line is going down. Now we need to do fall over run, right? So to go from this point to this one, how much are we falling?
Would it be B over A?
It will be B because, I mean, this side is the same as this side, okay? So it will be B down, A to the right. Do you see that? So that's negative B over A. You okay with this?
Yeah.
Let's multiply. Now that we have stuff to work with, let's multiply them. So what happens when you do M1 times M2? What do we get? Well, let's see. M1 is A over B, and M2 is negative B over A. So what happens here? The A's cancel, the B cancel. So what do we get? Negative 1. I mean, when you cancel, you have 1 left. Remember, we're divided, right? So it's a 1 here, 1 here, 1 here, and 1 here. So you get negative 1. Moral of the story. I mean, this is how you believe the result. Really, all you have to remember is this last part. If you have a particular line, what's going to happen is when you multiply the slopes, you get negative 1. Okay? So that's, I guess, conclusion number 4. So we can say all of those things, but then the important one is number 4, which is if you do M1 times M2, the result is negative 1. Okay? So what we just did above is the proof of the following theorem. So this is a theorem. Two lines are perpendicular two lines, let me say here, with non-zero slopes, okay? Because this is very special. Here the product is not -1 because one of them that does not exist, okay? So two lines with non-zero slopes are perpendicular if and only if, that means it works both ways, okay? If and only if the product of their slopes is -1. Okay, so when you multiply the slope, you get -1. That's how you can tell that the lines are perpendicular. So if the product is -1, they are perpendicular. And also, if you know that they are perpendicular, you know now that the product must be -1. It goes both ways.
It can only be -1?
Yes, we just prove it.
What if it's -2?
Cannot. We just prove it.
I don't know, I'm just asking.
Look, we just did this. We didn't assume anything special about the lines, just that they intersect at 90 degrees. So if they intersect at 90 degrees, we can always play this game.
Because if it was -2, it would be wider and it wouldn't be.
Exactly, because when you do the rotation, you're not going to get the same picture. You see, that's why 90 degrees is so nice, because when you rotate, you get exactly the same picture.
So if I saw a perpendicular line in my homework, I would know -1 is.
The product of the slope is -1.
If that was a question, I would know immediately.
Of course, because that's the characterization. Okay, so here is something else that we can say. So equivalently, so this is telling me that M1 times M2 is equal to -1, but you can also write that M1 is -1 over M2, right? Just move this guy over here, divide it, or the other way around, okay? In other words, that the slope of one line is the negative reciprocal of the other one. So as a concrete example, if you know that M1, or let me say M2, if you know that M2 is -1/2, then what is M1? All you have to do is flip it and change the sign. So if M2 is -1/2, then M1 has to be +2. You just flip it, okay? If M1 is 4/3, then M2 would be -3/4. Just flip it and change the sign, okay? That's what this is telling me here, which is equivalent to say that when you multiply them, you get -1, okay?
That's what I said earlier. But I told you about the negative, the one negative.
Yeah, the product is negative. That's what we're saying. Right here. Do you understand this? So let me summarize. When you're given two lines, two things can happen. Actually, now we can say three things can happen. Either they are parallel, they are perpendicular, or they are neither. Okay? How can you tell? Well, you look at the slopes always. You compute the slopes. If the slopes are the same, parallel, done. If they are not the same, okay, you know that they are not parallel, so it's either perpendicular or neither. So how do you know if they are perpendicular? Multiply them. If you get -1, perpendicular, done. If none of those two cases happen, then they are neither. Does that make sense? So let's do some examples with that. I guess, let me summarize. So summary. So given two lines with slopes M1, M2, let me say non-zero, so that everything works. Then let's say number one, if M1 is equal to M2, then they are parallel. If this doesn't happen, but we have that M1 times M2 equals -1, then they are perpendicular. And then we can say here, if one or two don't work, we say they are neither. And when we say neither, we mean neither parallel nor perpendicular, okay? But for shorthand, we just say neither, okay? It's understood that we mean neither parallel nor perpendicular. Okay, any questions? All right, then let's do some examples. All right, so here I have some problems written down. let's do those. So let's do number 1 together as a little warm up. Then let's see, I'm gonna do A, and then you're gonna do B, C, B and C, and then of course we do it together. So to give you some chance to work. Okay, let's see. Suppose a given line, I'm not telling you what the line is, I'm not even giving you a picture, but I'm telling you that there is a line and the slope is -4/3. Okay? Now I want you to tell me the slope of another line that's parallel to this one, and I want you to tell me the slope of another line that's perpendicular to this one. Okay? So let's see, what will be the answer for A? What will be the slope of a line that's parallel to the one that I'm giving you, the one that I'm talking about? -4/3, because they have to be the same, right? Okay, and now what will be the slope of the one that's perpendicular, of a line that's perpendicular to this one? What is it?
Positive 3/4.
Positive 3/4. Remember, you have to flip them and change the sign. Okay? Questions? Do you understand this? Remember, parallel, same slope. Perpendicular, flip it and change the sign. If you are given something negative, you have to make it positive. If you have something positive, you have to make it negative. Okay? Because remember, you want the product to be -1. The flipping is to get the 1, and the changing the sign is to get the negative. Okay? All right. So now let's do something similar, but now this time I'm going to give you 2 lines, and then your job is to determine what's going on with them. Are they parallel, are they perpendicular, or are they neither? And we will do this without graphing. Okay? In other words, looking at the slopes. Now remember, a line itself can be given to you in different ways. Remember, all I have to do is give you 2 points, and that's enough for me to talk about a line, because you can draw it, right? So I could give you 2 points, or I could give you equations. So the first example deals with how do you do this if you're given the points, and the others, how you do it if you're given the equations instead. All of those are equivalent ways of giving you lines. So let's do A together. So let's see. My first line is given by the points 4, -1. So this means this is the line that passes through these 2 points, okay? And the second line is the line that passes through -1, 3 and 2, 0. Okay, and we want to determine, oh, by the way, let me back up. Let me give you a notation, because writing the word parallel and perpendicular is painful, because they are a little bit long. Not so much parallel, but perpendicular is a little bit long. So we have a notation for this. So when lines are parallel, we write this. We write a pair of little lines like that. So we say L1. If you see this means L1 is parallel to L2. Okay? That's the notation for parallel lines. So this symbol here means parallel in math. And if the lines are perpendicular, we write L1, and then we do like an upside down capital T, and then we write L2. This symbol here stands for perpendicular. Okay? So when you see this reads L1 is perpendicular to L2. Okay? So it's just a shorthand notation. Symbol that we use for that. Have you seen these symbols before? Yeah. Okay. That's not new. All right. So, wait, what did I do? Okay. So our job is to determine whether L1 is parallel to L2, perpendicular, or neither. Okay. How do we do this? What do we need to know to be able to answer the question? We need to know the slopes, right? So the first thing is, are we given the slopes? No. So our first task here, even if we are not asked to do so, is to find the slopes. Okay? So first thing that we need to do is we need the slopes. We need the slopes. All right, let's find them. So remember, we have a formula, right? If you are given 2 points, can you find the slope of the line? Yes. So let's do it. So M1, remember, is y2 minus y1 over x2 minus x1. Which one is your point 1 and which one is your point 2 is up to you. whatever you want. I'm just gonna say the first one is my 0.1 and this one is my 0.2. Okay? And make sure that you work with these points and not one from here and one from down here. Okay? Because those are for different lines. All right, so let's just plug in. So difference of the y's, so that's 6 minus 1. Be very careful because there is a minus as part of the formula, and then my y1 is also negative, so you have to put a parenthesis here, okay? Because now minus minus becomes positive, so you have to be careful there. Over difference of the x's, so negative 3 minus 4. Also, understand that you have to be consistent, so whatever you decide to put as your first y here, it has to match the x down here. It has to be the corresponding x. So if I put 6 over here, I have to put negative 3 first in the bottom. You cannot put 4 first. Okay? So just be consistent. All right, so that will be 6 plus 1, which is 7, over negative 7, right? So what do we get? Negative 1. So by looking at this, we know the slope of the first line is negative 1. What can you tell me about this line? Is it going up or down?
Down.
It's going down. So we know this line is going down and it has slope negative 1. You don't know anything else. Don't say perpendicular. Perpendicular is the product. Be careful.
Oh, okay.
Remember,
I
it's
saw negative 1 and I got
the product, so you have to be careful. Okay, so we have our first slope. Now, compute the second slope. So again, same formula. And now we're plugging in the other points. So let's see. Let's do 0 minus 3 over 2 minus 1. So we get negative 3 over. Now that's 2 plus 1. That's 3. So what do we get?
Negative 1.
Negative 1. Okay, so we have the two slopes. Now that we know the two slopes, what can we say about the lines? They are parallel. Same slope. Be careful. Don't be thrown off by the negative 1. Okay? Remember, my advice to you is do in this order. First, see if they are the same. If they are the same, parallel. You're done. If they are not the same, now test the product. If the product is negative 1, okay, perpendicular. If that doesn't work either, then you say neither. Okay? So do it in that order. All right, so from here we can see that M1 equals M2. It happens that they both happens to be negative 1, but that's okay. They are equal, so the answer is parallel. So L1 is parallel to L2. Do you understand this? So the lines are parallel, okay? Questions? All right, so do the same thing for B and C. Again, the first thing that you need to do is figure out the slopes so that then you can decide. In this case, notice that I'm giving you the equation. So instead of using the formula, what do you need to do? What we did at the beginning today. Write the equation in slope intercept form, each of them, and then get the slope from there and decide. For example, what's the slope of the first line? Negative 3. That one is already given to you in slope intercept form. So all you have to do now is figure out the slope of line 2 and then decide. Okay? And similarly for C. You take attendance while you do that. What do you think about this one?
Easy.
Okay, what is it?
Okay, yes.
What's the answer?
The answer.
Yeah.
The lines are perpendicular.
Perpendicular? Perpendicular. Is everybody getting the same thing?
Can you do that?
We do it, but I want to see what the answers you have. Let's see, to do this, what do you need to do?
Get the slope of both.
Get the slopes, right? Let's see, what's the slope of the first line? That's everybody? Negative 3, not the x. Slope is a number, yes? Does everybody understand the first slope is negative 3?
Yeah.
Okay, what did you get for the second slope?
Positive 1 over 3.
Positive 1 over 3. Is everybody getting the same thing? Yes or no?
Yes.
I mean, here is the key, find the slope. So let's see, let's do it. So again, to find the slope, what can you do? Well, solve for y, okay? So to solve for y, first you have to leave it alone. So anything that doesn't have a y, move it to the other side. So any term that doesn't have a y. X doesn't have a y, so bring it to the other side. So that becomes negative 3y equals negative x plus 4. Yes? And now we get rid of the coefficient, which is -3. So we divide everything by -3. So we get y equals, now negative divided by negative is positive. They cancel. So you get 1/3. So that's 1/3x minus 4/3. Yes, this is what we did at the very beginning today. Very first example. So we put in slope in this form. Now we can easily read the slope from here. What's the slope? 1/3. Now, looking at it, what can we deduce? Let's see, are the slope the same?
No.
Let's see, so we can say, so step number 1, okay, M1 is not the same as M2. So for sure you know that they are not parallel. Okay? All right, next, are they perpendicular? Well, what do we need to check?
You multiply.
So is the product equal to -1, or visually are they the negative reciprocal of each other? In other words, if you flip one and change the sign, do you get the other one?
Yes.
For example, here is a -3. If I flip it, what do you get? 1/3. If I change the sign, it becomes positive. That's exactly what we have here. Or backwards. Flip this one, you get your 3, and because it's positive, you make it negative. Right? Or you want. So perpendicular. But that means that when you multiply, you actually get -1. Then let us now look at the product. Well, -3 times 1/3, that's -1, because the 3 is cancelled. So the lines are perpendicular. Okay, so we can say here that L1 is perpendicular to L2. So, I mean, there are two things here. You have to be able to find the slope and then, use the theorem accordingly, do the correct comparison. Do you understand how to find the slopes?
Yes.
Yes? And then once you have the slopes, do you understand how to decide what's going on? Okay. So, did you do C?
I didn't see the question.
So, try it. So remember, the first job is to find the slope. So you have to worry about that first. Put it down. So let's see. Look, guys, it's very easy to see a slope without even having to write anything. You can just do it in your mind. Just moving things around, okay? You just follow it along. Like here, you have to move this over here. So what do you have? Just focus on what's in front of x. If I move this over here, what do I have in front of x? What do I have? -5, right? And then what do we need to do? Get rid of the 4. Divide by 4. So now what do we have in front of x? -5/4. That's it. Do you understand what I'm saying? It's not supposed to be hard. How about this one? What do we have in front of x when I move it? And then what do we do? So what's the slope? -4/5. Yes? So again, it should not be too complicated to be able to just look at it and tell immediately what the slope is. Okay? Just move it. All right, so let's do it. So first we write in a slope intercept form. You know the drill. Divide by 4, so we get -5/4x plus 1/4. Okay? Remember, everything has to be divided by 4. So from here we get the first slope, which is -5/4. All right, now repeat. So for y, move the x to the other side. Now divide by 5. This is what we get. So second slope is -4/5. Okay. What can we say?
Not parallel.
They're definitely not parallel. Why? Because they are different. Does everyone understand this? Okay, next. Are they perpendicular?
No.
Why?
Because if you flip the sign, it wouldn't be the same. I mean, it wouldn't equal to negative one.
Very good. Notice that they are reciprocal. I mean, they are reciprocal of each other. If you flip one, you get the other one. It's just that you have to remember they have to have different signs, right? One must be positive, the other one has to be negative. Otherwise, the product will not be -1. This product is positive. If you multiply the two lines, that is going to be +1. If you multiply the two slopes. Do you understand this? So you see that they have the same sign. You don't even have to worry about the flipping. Same sign, that's it. They are not perpendicular. Okay? So in this case, it's neither. So we say, okay, M1 is different than M2, so not parallel. This is the thought process. Then M1 times M2 is actually positive. You can just say positive, but if you want, it's equal to +1. Okay? Let me write it down. That's -5/4 times -4/5. Negative and negative cancel, and then actually everything cancels, right? 5 and the 4, so you get +1. So this is not -1, so not perpendicular. So if they are not parallel, if they are not perpendicular, they are neither. Okay? The answer here is neither. Okay, so you can tell that by just looking at the little numbers. There is no need to draw and do anything more fancy. Okay? All right. Any questions? All right. So